This lecture video is about graphing quadratic functions. Another name for a quadratic function is a parabola. So many of you may have heard of it being called a parabola before, and they look like a big capital U when they're graphed. And they can be either opening up like the first one I drew here or opening down like the second one that I drew. The function has the form f of x equals a, so this is some kind of constant, so some number a, times the quantity x minus h squared plus k. And the vertex is at hk. The vertex is this very bottom or this very top point. So those are the vertex of the parabola. Oops. And also this point up here would be the vertex on that parabola. So notice that this is x minus h, and the x-coordinate for the vertex is just a plain old h. So you basically change the sign of the number that's inside the quantity being squared, and this number stays the same, and we'll look at that a little bit later on. So once you have the vertex, then you need 4 other points on the parabola, and all parabolas follow the same pattern, and so you can use the pattern from the vertex to find the other points. And so if this is your vertex, hk, then to get 4 other points, the way that you could do that is you would move to the right 1, and then you would go up by a, whatever the constant a is, and there would be another point right at that location. And then you could go right 1 more from that point, and then go up 3 times a. And then you follow the same pattern on the other side. So you would go left 1 and up a. And then there would be a point right there, and then you would go left 1 again, and then up 3 times a. And there would be a point at that location as well. So that's how you can find these other 4 points that you need other than your vertex, which is at the point hk. Another thing to notice is that if a is greater than 0, then the parabola opens up. So the parabola will have this shape. If a is some number that's less than 0, then the parabola opens down. And so it would look like this. Okay? So let's take a look at graphing some of these. Our first one, f of x equals x squared plus 2. So notice there is nothing being subtracted from the x, so we could actually rewrite this as f of x equals x minus 0, that quantity squared. X minus 0 is just x, and so that's how you get the x squared there, and then plus 2. So when you have it written like this, then you can see very clearly that the vertex then would be at the point 0, 2. So here's 0, 2. And this parabola is opening up because a is equal to 1. And so to get our other points, we're going to go to the right 1 and up by a, but a is just 1. So we're going to go right 1, up 1. And then right 1 up 3 times a, and since a is 1, we're going to go up 3. And then do the same pattern on the left, go left 1 up 1, and left 1 up 3. When you're graphing, make sure that you label all the points that you plot. So that was 0, 2, this is the point 1, 3, and this is the point 2, 6. And on the other side, we have the points negative 1, 3, and negative 2, 6. And then draw in your curve and make sure that you put the arrows on the end, indicating that it goes on forever. In our next example here, so we have a value being subtracted from x in the parentheses, but there's nothing out here, so it's like having a plus 0 out here. And so our vertex for this one, so remember we have to change the sign inside the parentheses, so it's x minus 2, so that means that the x-coordinate of the vertex is positive 2, and then there's nothing being added out here on the end, so that means the y-coordinate is 0. So our vertex for this parabola is at the point 2, 0. So here's our point 2, 0. A again for this one is 1, so that means that it's opening up. So we're going to go right 1, up 1, and left 1, up 1. And then from our two new points, we go right 1, up 3, because that's 3 times A. And then left 1, up 3 for the other point. So we have the point 2, 0 as our vertex, and then 3, 1, and 4, 4. And over on the other side, we have the point 1, 1, and 0, 4. And then we draw in our parabola. And before I forget, we should do domain and range for these. Domain for any of these parabolas is always going to be negative infinity to infinity. So it goes to the left forever and it goes to the right forever. And then the range is going to be from the vertex on up for a parabola that opens up. So this vertex is at 2, and it goes up forever, so to positive infinity. This one, domain, all of them are going to have a domain of negative infinity to infinity. And the range, so this parabola starts at y equals 0 and goes up forever, so 0 to infinity. In our next example here, f of x equals the quantity x plus 1 squared minus 3. So our vertex, we have to change the sign of this one. So the x-coordinate is going to be negative 1, and this one stays the same. So our y-coordinate is negative 3. A for this is the number in front of this quantity being squared, and there's nothing there, so there's an implied 1 there. So that means that it opens up, because 1 is bigger than 0. So negative 1, negative 3 is right here. Left 1 and down 3, and this parabola is opening up. Our A is 1, so we're going to go right 1, up 1, right 1, up 3, left 1, up 1, and left 1, up 3 to get our other points. So this is the point 0, negative 2. Here we have the point 1, 1. And over here we have the point negative 2, negative 2. And here we have the point negative 3, 1. And then draw in your parabola. And our domain, negative infinity to infinity. It's the same for all parabolas. And then the range, so we go from the vertex up. The vertex here starts at negative 3, and this goes up to positive infinity. Example D, f of x equals 1/2 x squared. So again, if you want to have it looking just like the form that we had before, we could rewrite this as f of x equals 1/2. And then there's nothing being subtracted from x here, so it would be x minus 0 squared. And then there's also nothing being added on outside, so that's plus 0. Okay, so this is just x in here, so this would give me 1/2 x squared, and then this is nothing out here, so that would lead to that equation. The vertex then would be at the point 0, 0. And this A for this one is 1/2. And that's bigger than 0, so it opens up. So our vertex is right at 0, 0. We go right 1 and up by A. A is equal to 1/2. So we go up by 1/2. And then right 1 up 3 times A. Well, I'll write it as 3A. And then, so that's 3 times 1/2, which is 3/2, or 1.5. So go right 1 and then up 1.5. So there's a half, and there's a full right there. And then do the same on the left. Go left 1 up a half, and left 1 up 1.5. So our vertex was at 0, 0. This is the point 1, 1/2. And this is the point 2, 2. And on the other side, we have negative 1, 1/2. And negative 2, 2. Okay, and then you can draw on your parabola. And one thing to notice is what this actually does to the graph. I'll just, in blue here, draw in the parabola f of x equals x squared. Okay, so this one also has its vertex at 0, 0, so I'm just going to draw a circle around it, indicating that that's my vertex for this parabola. This parabola has a equals 1, because there's no number in front of it, so I just want you to see exactly what this number does to our parabola. So with a equals 1, we would go right 1 up 1, and then from that point right 1 up 3. On the left, we would go left 1 up 1, and left 1 up 3. Okay, so when you have a number in front of here that's a fraction that's less than 1, so 1/2, 2/3, 3/5, something, as long as this fraction is between 0 and 1, it's going to make your parabola flatten out a little bit, so it's like it's squished. So this parabola is wider or fatter than the blue parabola. If this number is something bigger than 1, so let's put on the same graph, and I'll do this one in red, just so you can see them all on the same graph and what happens as this number changes. So now this is 2, so it's still opening up. It still has its vertex at 0, 0, so I'll put a little red dot there. And then instead of going right 1 up 1, we're going to go right 1 up 2. And then for the next point, we would go right 1 up 2 times a, so that's going to be 6. Or 3 times a, sorry. So we have to go up 6 from there, which is going to be up at 8. Do the same on the left, go right 1 up 2, and then right 1 up 6. And so when you have a number that's bigger than 1 in front of x squared, then your parabola gets taller and skinnier. So a number bigger than 1 makes it taller and skinnier. A number that is less than 1 makes it shorter and fatter. So I just wanted you to see that all on one graph. So let's go up to our next example here. So we have f of x equals negative 3x squared. So again, there's nothing being subtracted from the x, and there's no constant being added out here. And so our vertex is at the point 0, 0 again. And a this time is negative 3, and that's less than 0, so it opens down. So my vertex is right here at 0, 0. I'm going to go right 1, and instead of going up, we're going to go down this time. And we go down by a, so we have to go down to negative 3. And then right 1 and down 9. So that's going to be off my graph, unfortunately. So way down here. And then go left 1 down 3, and then left 1 down 9. We have to go down. So we have 0, 0, and then 1, negative 3, and then from there we went down 9, so this should be the point 2, negative 12. And then we have negative 1, negative 3, and this should be negative 2, negative 12. And then you can draw in your parabola. Okay. Oh, and the domain and the range. I always forget that. So negative infinity to infinity for the domain and the range. So this time the vertex is at the top of the parabola, so we want to start from the lowest values and go up. So our domain starts down here at negative infinity, and it goes up to 0. And you have to make sure that you put it in this order. It's always, when you write an interval, the smaller number and then the bigger number. Let's see if I did the domain and range for that one, and this one I did not do the domain and range for, though. So the domain, always negative infinity to infinity for a parabola, and the range is from the vertex on up. So that would be from 0 to infinity. Okay, in our next example here, we have 2 times the quantity x plus 1 squared, and then there's nothing added on the end down here. So our vertex, you have to remember to change this sign, so that's going to be negative 1, and there's nothing out here, so that's 0. So our vertex is at negative 1, 0. There's my point, negative 1, 0. A for this parabola is equal to 2. That's the number out here. And so that means that this opens up because 2 is bigger than 0. And so we're going to go right 1 up 2. Remember, we go right 1 and up A. And then from there we go right 1 and up 3 times A. And 3A is going to be 6. So we want to go up to 8 here. And then left 1 up 2 and left 1 up 6. So we have negative 1, 0 is our vertex. We have 0, 2 and 1, 8. And on the other side here we have negative 2, 2 and negative 3, 8 are our other points. Draw in your parabola. And our domain is always negative infinity to infinity, and the range, start at your vertex and go up. So that's 0 to infinity. Couple more examples here. This next one, A here is 1/2. So that's bigger than 0, so it opens up. And we have x minus 2 the quantity squared plus 1. So our vertex, change this sign, so that would be positive 2. And then this sign stays the same, so positive 1. So our vertex is at the point 2, 1. So there's our point 2, 1. Our parabola is opening up, and A is 1/2. So we're going to go to the right one, up 1/2. And then right one up 3 times A, so that's 3 times 1/2, which is 3/2 or 1.5. So right one up 1.5 puts us up here at 3, and then go left one up 1/2 and left one up 1.5. So my vertex was at the point 2, 1, and this is the point 3, and then we went up 1/2, so that's 1.5. And then this is the point 4, 3. And on the other side here, we have the point 1, and then this is 1.5, and then 0, 3. And then you can draw in your parabola. And the domain is from negative infinity to infinity, so it goes to the right forever and to the left forever. And then the range, so this one is starting at positive 1, and it goes up forever. So that would be to infinity. Our next one, negative 2, is A. So A for this one is negative 2, so it opens down. And times the quantity x minus 3 squared plus 4. So our vertex, change the sign of this number in here, so that's going to be positive 3. And this number stays the same. So 3, 4 is our vertex. And it's opening down. And A is 2, negative 2. So we go right 1 down 2, and then right 1 down 6. Go left 1 down 2, and left 1 down 6. So I have the point 4, 2, and this is the point 5, negative 4. And over here we have the point 2, 2, and 0, negative 4. And then we can draw in our parabola and find our domain, which is negative infinity to infinity, and the range. So again, this is a parabola opening down, so we start down here. It goes down forever, so that's negative infinity. And then it stops right here at x equals, or y equals 4. So our range is negative infinity to 4. And that finishes up our lecture on graphing quadratic functions. There's another video on graphing quadratic functions, and that will be with parabolas in a slightly different form. So if you have any questions, let me know. Thanks.